Welcome to Journey Through Time, to a journey far beyond the ordinary. Tonight, we're not charting the stars or the birth of galaxies. We're looking down, under our own feet, into the slow, deep breathing of the planet itself. And I want to ask you a question that feels simple, but cuts to the heart of curiosity. What if we're not the first? Not the first thinkers, builders, explorers? What if, millions of years before our monuments and satellites, before agriculture or written words, another civilization rose here and vanished so completely that even the Earth forgot? It sounds like science fiction. It is, partly. But it's also a serious scientific question. For years, a quiet conversation has flickered at geology labs and cosmology conferences. How would we even know if a civilization came before us? Not skyscrapers under ice, but subtler signals, chemicals, isotopes, layers of rock. Because cities, tools, even bones, dissolve in the churn of deep time. We think of ancient as thousands of years, Egypt's pharaohs, Stonehenge, clay tablets. In geologic time, that's a blink. Earth is 4.5 billion years old. Continents drift, oceans open and close, mountains rise and crumble. Surviving for millions of years is extraordinary. Most traces vanish long before that. Now picture an intelligent species 100 million years ago. Maybe it walked on land, maybe it swam in oceans, maybe it built with materials we'd never recognize. Maybe it had culture, technology, memory, and then faded. We arrive millions of years later asking whether it ever existed. Even our own civilization isn't permanent. Leave a city untended for a century, and plants begin to take it back. Give it 1,000,000 years, and tectonics, erosion, and subduction erase almost everything. The ocean swallows coasts, glaciers grind mountains, and our footprints fade into sand. Geology isn't cruel. It's thorough. Earth keeps no diary. Wood rots, metal rusts, bones dissolve. Fossilization is rare. Rapid burial, mineral replacement, geological stability. Even dinosaurs are rare. If life barely leaves a mark, how can civilization expect better? Two scientists asked this in 2018. They called it the Silurian Hypothesis, a playful nod to a British sci-fi race of ancient reptiles. They didn't claim such a civilization existed. They asked, if it had, what would survive? Their answer: not buildings or monuments, but chemical fingerprints, strange isotope ratios, synthetic molecules, rare elements embedded in ancient sediment. Look at ourselves. We're leaving a chemical layer in Earth right now. Plastics in oceans, concrete in soil, nitrogen in the atmosphere, radioactive isotopes from nuclear tests. That's our fingerprint. But how long will it last? Millions of years? Or will Earth scrub it clean? So the real question isn't, did someone come before? But, could we even tell if they did? The geological record is incomplete. Layers erode or never form. Ocean floor recycles every 200 million years. Even giant asteroid craters vanish under tectonic churn. Civilization isn't just pyramids and writing. Some societies had no monuments but still counted as civilizations. Urban life, trade, rituals, complexity. If we're only looking for giant stone structures, we'll miss a lot. Think of Çatalhöyük. No streets, no writing, no monuments, yet a true urban settlement. Or termite mounds, ventilation, farming, climate control. But we call them nests. Scale that up, bury it for millions of years, and you'd never know it was engineered. Intelligence doesn't have to look like us. That's why geologists hunt anomalies instead of ruins. Unexpected chemical shifts, unusual mineral concentrations, strange isotope ratios. And a civilization doesn't need millions of years to leave a mark. Just a few centuries of industrial activity can rewrite climate, chemistry, and ecosystems on a planetary scale. We're doing it now. Before we hunt for forgotten civilizations, we have to understand the forces that erase them. Earth is not a still stage. It's alive, restless, and constantly rewriting itself. Every stone and coastline you know is temporary. What looks solid in our lifetime is just a moving skin in geologic time. Start with weathering. Rain, frost, heat, and wind chip away at even the hardest rock. Roots pry apart concrete, metal corrodes, wood rots, entire bridges collapse under their own rust. A city abandoned for a few decades becomes a ruin. A ruin left for centuries becomes rubble. After 1,000,000 years, it's indistinguishable from the landscape, its steel and stone reincorporated into soil and sediment. Then there's sedimentation. Dust, ash, and sand build layer upon layer, burying whatever lies beneath. Burial can preserve fossils or artifacts for a while, but it also crushes and distorts them. Minerals replace organic material. Layers compress into stone. After a few million years, that buried skeleton or building becomes a faint imprint, if it's there at all. Most vanish entirely, recycled into new rock. And beyond burial lies tectonics. Earth's outer shell isn't a single crust. It's a patchwork of plates drifting on molten rock. They collide, split, and slide past each other. Earthquakes reshape the surface. Mountains rise and erode. Ocean floors spread and subduct. Subduction is Earth's delete button. Entire ocean basins, with all their sediments and secrets, are dragged back into the mantle. The average ocean floor is only about 200 million years old, ancient by human standards, but a blink compared to Earth's age. Even continents don't last perfectly. Erosion wears them down. Glaciers scrape them clean. Volcanoes bury them under ash and lava. Rivers shift course. Deserts migrate. Forests come and go. Even impact craters fade. What seems permanent from our perspective is just a snapshot of motion. Geologists see this everywhere. The Grand Canyon looks like a neatly layered book, but whole chapters are missing. Gaps called unconformities. The rock record isn't a complete archive. It's fragments stitched from what survived. Even with human history, we're left with scraps. A flint knife, a pot shard, a post hole in the soil. Archaeologists reconstruct entire cultures from fragments, because that's all time leaves. If that's true for tens of thousands of years, what chance does anything have after tens of millions? And yet we search. We've learned that the strongest signals aren't bones or buildings, but chemistry. Shifts in carbon isotopes, rare elements, synthetic compounds. These can last longer than stone. That's what the Silurian Hypothesis suggests. Stop looking for monuments. Start looking for fingerprints. We know we're leaving our own fingerprints right now. Burning fossil fuels changes the carbon ratio in the atmosphere, a signal that ends up locked in ice cores and sediment. Plastics become microfragments embedded in soils and oceans. Nuclear tests leave isotopes that don't occur naturally. All of this becomes a thin, strange layer in Earth's crust. That's our real fossil. Not buildings, but a chemical line. But here's the twist. Natural processes can mimic these signatures. Volcanoes can release carbon. Microbial blooms can shift isotopes. Asteroid impacts can scatter rare metals. Earth has its own vocabulary of disasters. Without context, anomalies look like nature. Even if we did find something like our own fingerprints in the deep past, it would be hard to argue it was artificial. And then, there's the ocean. Covering 70% of the planet, it's the ultimate eraser. Coastlines, where most of us live, are the least stable environments. Sea levels rise and fall by hundreds of meters over ice age cycles. Coastal cities sink beneath the waves, and the ocean grinds them to silt. The seafloor itself is subducted and remade. Myths of drowned cities, Atlantis, Lemuria, lost lands, persist but rarely leave proof. The ocean doesn't preserve, it dismantles. Wood decays, ropes rot, stone crumbles, metal corrodes, even concrete breaks down under saltwater and shifting sediment. Buried fast enough, some traces might survive for a while. But after millions of years, even towers would be unrecognizable lumps, if anything at all. Remember, we've mapped the moon in more detail than the deep ocean. Most of the seafloor is still unseen. Sonar resolution is low. We can find seamounts and trenches, but not the subtle geometry of a buried harbor or a collapsed city. Without a clear target, we're searching blind. If an ancient civilization poured waste into the oceans, mined the seabed, or altered marine chemistry at a planetary scale, it could leave a geochemical signal. Microplastics already reach the deepest trenches. Mercury, lead, and radioactive isotopes spread worldwide within years. Some residues might persist tens of thousands of years, maybe longer under anoxic conditions. But to stand out after millions of years, the changes would have to be massive and global. Even then, the signal would look like chemistry, not civilization. A spike of titanium dust in a 100-million-year-old core sample could be a factory's byproduct or a meteorite. Without context, we'd never know. This is the lost tech test. Could any trace of advanced technology survive for tens of millions of years? And would anyone recognize it if it did? When direct evidence runs dry, what's left are stories. Myths passed down through generations, reshaped and retold until their origins blur. But myths can outlast buildings. They survive language shifts, migrations, even disasters. And sometimes they preserve faint memories of real events. Cultures across the world tell of floods, lost lands, fire from the sky, or golden ages ending in catastrophe. Sumerian, Babylonian, Hindu, Norse, indigenous. The details vary, but the core themes repeat. A world before, then a deluge, destruction, or loss. Maybe these are just metaphors for human vulnerability, or maybe they're echoes of real floods, sea level rises, or disasters now buried beneath millennia of sediment. Take the flood myths. They appear everywhere. Mesopotamia, India, Scandinavia, the Americas. During the last ice age, seas rose more than 100 meters, drowning entire coastlines. People would have seen their world vanish. Their descendants would have remembered. A myth might hold a grain of history, compressed into a story of gods and heroes. Or consider lost lands, Atlantis, Mu, Lemuria, Kumari Kandam. These places are often described as advanced, beautiful, and doomed. The reasons for their fall differ: hubris, war, cosmic punishment. But the endings are always the same. The land sinks, the people vanish, and only the tale remains. These aren't evidence of a forgotten civilization, but they hint at how collective memory works. Real events distorted over thousands of retellings. There's another theme: lost knowledge. Myths of an age when humans knew more. Stars, machines, secrets of nature. Tales of flying vehicles, powerful weapons, cities in the sky. Most of these are clearly symbolic, but sometimes the details get oddly specific. Defenders of the myth as memory idea suggest these could be faint recollections of something real, passed down orally, long after the original context vanished. Modern anthropology has begun to take oral tradition more seriously. Indigenous stories have proven surprisingly accurate when matched with geological or archaeological evidence, describing river courses, volcanic eruptions, or glacial retreats centuries before written records. Myths aren't proof, but they're not nothing either. They're compressed history, metaphors with roots in experience. But even if stories hold fragments of truth, they're not enough. We also have objects, things dug from the earth, sometimes out of place. A carved stone in the wrong layer, a metal fragment in ancient sediment. Most turn out to be misinterpretations, contamination, or natural formations. Yet a few remain unexplained, sitting quietly in the margins of science. These anomalies keep the question alive. Could a real signal be hidden among the noise? Take OOPArts, out-of-place artifacts. Miners in the 19th century claimed to find metal chains in coal, carved bells, or stones etched with strange patterns. Most were anecdotal, poorly documented, or lost. Skeptics point out that mining mixes layers, contamination is easy, and human pattern seeking does the rest. But the stories show what people expect to find: tangible proof of an earlier world. Or the Klerksdorp spheres, small grooved objects found in South African mines, embedded in 2-billion-year-old rock. Fringe theorists said they were manufactured. Studies showed their natural concretions formed under pressure. Fascinating but not artificial. This is typical. Almost every anomaly, once studied deeply, turns out to have a natural cause. Yet science moves cautiously. It favors repeatable evidence and known mechanisms. Without overwhelming proof, no one claims civilization as the answer. Extraordinary claims need extraordinary evidence. And so anomalies linger in limbo, unexplained, not proven artificial, but not entirely dismissed. Some anomalies aren't objects at all, but chemical signals. Sudden global shifts in isotope ratios, strange metal concentrations, abrupt warming events. The Paleocene-Eocene thermal maximum 56 million years ago looks in some ways like our own industrial footprint. A spike in carbon, ocean acidification, mass extinctions. As far as we know, no civilization caused it. But the similarity makes some scientists wonder quietly. If a technological species had existed, would its impact look any different from a natural catastrophe? The honest answer: we don't know. Earth's disasters and industry produce overlapping fingerprints. Without context, they're hard to tell apart. A thin layer of titanium could be a factory or a meteorite. A carbon spike could be volcanoes or coal-burning machines. Only a pattern of multiple signals, synthetic compounds, isotope shifts, rare elements, would begin to look artificial. This is why the Silurian hypothesis matters. It's not about proving someone came before us. It's about testing our methods, questioning our biases, and looking at Earth with fresh eyes. It's about humility, accepting that the absence of evidence isn't always evidence of absence, especially when timescales dwarf our imagination. Because history isn't a line. Earth's record isn't a timeline. It's a palimpsest. Pressure, heat, erosion, and tectonics rewrite it constantly. Most of whatever lived, built, or dreamed has been recycled. If another civilization left a mark, it's probably not a statue waiting to be discovered. It's a chemical echo in stone. And so we keep looking, not expecting buried cities or alien machines, just the quiet possibility that deep beneath our assumptions lies a signal. Not a message in words, but a pattern in data. Not left intentionally, but left all the same. When we talk about fossils, we picture perfect skeletons in museum halls. But real fossils aren't like that. They're fragments, impressions, mineral ghosts. Fossilization is an exception, not the rule. Most living things leave no trace at all. They decompose, dissolve, or are eaten. Only under rare conditions, rapid burial, mineral replacement, geological stability, do they survive. Even then, exposure or tectonic shifts can erase them later. If it's this hard to preserve bones, imagine preserving culture. Tools, fabrics, metals, inscriptions. Most wouldn't last thousands of years, let alone millions. Even stone tools can be mistaken for natural rocks without context. Metals corrode, plastics break down, digital data vanishes when the power dies. Entire civilizations could pass, leaving almost nothing obvious behind. So where do we look? Not for monuments, but for planetary changes. Mining, agriculture, energy use, these leave chemical scars. Synthetic molecules, isotope shifts, mass extinctions, redistribution of biomass. These are harder to undo and might outlast everything else. If someone millions of years from now digs a core sample of our time, they'll see a thin layer. Carbon spikes, nitrogen enrichment, traces of plastic, rare isotopes from nuclear tests. That's our fossil. Not buildings, but a chemical line. And even that won't last forever. Plastics degrade, radioactive isotopes decay, sediment shifts, subduction swallows. Without context, our layer might look like a natural anomaly, a blip, a weird spike, a curiosity. The Earth is patient, time is thorough, and the planet rewrites itself. So imagine you're a scientist far in the future, drilling into rock. You find a strange layer, higher carbon, synthetic compounds, a sudden loss of species. Would you call it civilization or a natural catastrophe? With no context, no artifacts, no myths, just chemistry, you'd be guessing. That's why the question of lost civilizations isn't fringe. It's a mirror. It asks us how we'd recognize ourselves in the deep past. It challenges our methods, our assumptions, our sense of permanence. It reminds us that intelligence doesn't guarantee immortality, and that the most advanced culture can vanish as completely as any species. We've seen how the ocean erases, how geology grinds, how myths distort. Yet some signals do persist. Isotope ratios can endure for millions of years. Certain ceramics and glasses may outlast steel. Subtle changes to soil chemistry can remain detectable long after fields have gone wild again. The trick isn't whether traces survive. It's whether anyone notices and whether they interpret them correctly. Because even today, scientists occasionally find anomalies in the geological record they can't explain. Most turn out to be natural, but some stay unexplained, sitting quietly in data tables, waiting for a question that hasn't been asked yet. Maybe one day someone will see a pattern where no one looked before. It's tempting to think of history as a straight ascent. Single origin, single story, us at the pinnacle. But Earth's deep time offers another picture. Cycles, experiments, resets. Intelligence may have arisen before, lived, and disappeared, leaving only whispers in stone. We can't prove it, but we can't rule it out either. And even if no one came before us, the exercise matters. It teaches us humility. It shows how fragile our own footprint is. If we can be erased, then permanence is an illusion. What we build, what we know, even what we believe, is temporary. The only lasting thing is change itself. So tonight, as you listen, imagine Earth not as a stage for one civilization, but as a vast, patient archive. Layers of forgotten stories, some natural, some perhaps not. Somewhere deep below, there may be signals we haven't yet learned to read. Not grand monuments, but faint fingerprints. Not a message written for us, but evidence that someone, once, was here. We may never find them. But the search reshapes how we see ourselves, not as the inevitable outcome of evolution, but as one more chapter in a book whose earlier pages have been lost. And that may be the most important discovery of all. The honest answer to all these riddles is simple yet unsettling. We don't know. Earth's disasters and industry produce overlapping fingerprints. Without context, they're hard to tell apart. A thin layer of titanium could be a factory or a meteorite. A carbon spike could be volcanoes or coal-burning machines. Only a pattern of multiple signals, synthetic compounds, isotope shifts, rare elements, would begin to look artificial. This is why the Silurian hypothesis matters. It's not about proving someone came before us. It's about testing our methods, questioning our biases, and looking at Earth with fresh eyes. It's about humility, accepting that the absence of evidence isn't always evidence of absence, especially when timescales dwarf our imagination. Because history isn't a line. Earth's record isn't a timeline. It's a palimpsest. Pressure, heat, erosion, and tectonics rewrite it constantly. Most of what ever lived, built, or dreamed has been recycled. If another civilization left a mark, it's probably not a statue waiting to be discovered. It's a chemical echo in stone. And so, we keep looking, not expecting buried cities or alien machines. Just the quiet possibility that deep beneath our assumptions lies a signal. Not a message in words, but a pattern in data. Not left intentionally, but left all the same. When we talk about fossils, we picture perfect skeletons in museum halls. But real fossils aren't like that. They're fragments, impressions, mineral ghosts. Fossilization is an exception, not the rule. Most living things leave no trace at all. They decompose, dissolve, or are eaten. Only under rare conditions, rapid burial, mineral replacement, geological stability, do they survive. Even then, exposure or tectonic shifts can erase them later. If it's this hard to preserve bones, imagine preserving culture. Tools, fabrics, metals, inscriptions, most wouldn't last thousands of years, let alone millions. Even stone tools can be mistaken for natural rocks without context. Metals corrode, plastics break down, digital data vanishes when the power dies. Entire civilizations could pass, leaving almost nothing obvious behind. So where do we look? Not for monuments, but for planetary changes. Mining, agriculture, energy use. These leave chemical scars, synthetic molecules, isotope shifts, mass extinctions, redistribution of biomass. These are harder to undo and might outlast everything else. If someone millions of years from now digs a core sample of our time, they'll see a thin layer, carbon spikes, nitrogen enrichment, traces of plastic, rare isotopes from nuclear tests. That's our fossil. Not buildings, but a chemical line. And even that won't last forever. Plastics degrade. Radioactive isotopes decay. Sediment shifts. Subduction swallows. Without context, our layer might look like a natural anomaly, a blip, a weird spike, a curiosity. The Earth is patient, time is thorough, and the planet rewrites itself. So imagine you're a scientist far in the future, drilling into rock. You find a strange layer, higher carbon, synthetic compounds, a sudden loss of species. Would you call it civilization, or a natural catastrophe? With no context, no artifacts, no myths, just chemistry, you'd be guessing. That's why the question of lost civilizations isn't fringe. It's a mirror. It asks us how we'd recognize ourselves in the deep past. It challenges our methods, our assumptions, our sense of permanence. It reminds us that intelligence doesn't guarantee immortality, and that the most advanced culture can vanish as completely as any species. We've seen how the ocean erases, how geology grinds, how myths distort. Yet some signals do persist. Isotope ratios can endure for millions of years. Certain ceramics and glasses may outlast steel. Subtle changes to soil chemistry can remain detectable long after fields have gone wild again. The trick isn't whether traces survive, it's whether anyone notices and whether they interpret them correctly. Because even today, scientists occasionally find anomalies in the geological record they can't explain. Most turn out to be natural, but some stay unexplained, sitting quietly in data tables, waiting for a question that hasn't been asked yet. Maybe one day someone will see a pattern where no one looked before. It's tempting to think of history as a straight ascent. Single origin, single story, us at the pinnacle. But Earth's deep time offers another picture. Cycles, experiments, resets. Intelligence may have arisen before, lived, and disappeared, leaving only whispers in stone. We can't prove it, but we can't rule it out either. And even if no one came before us, the exercise matters. It teaches us humility. It shows how fragile our own footprint is. If we can be erased, then permanence is an illusion. What we build, what we know, even what we believe, is temporary. The only lasting thing is change itself. Picture Earth as an immense palimpsest, layer upon layer, erased and overwritten, but still faintly holding the ghosts of earlier scripts. Now imagine trying to read a single word in that palimpsest after millions of years. That's what geologists and paleontologists do. They decipher whispers of ancient oceans, vanished mountains, extinct forests. But civilization, especially one based on ephemeral materials, would be an even fainter whisper. This is why the idea of a deep-time civilization stretches our imagination. It isn't about Atlantis or conspiracy theories. It's about recognizing how limited our sample really is. We've barely drilled a few kilometers into Earth's crust. We've mapped only fragments of the deep ocean floor. Our entire picture of deep history rests on incomplete data. Consider how small our human footprint is even now. The Amazon rainforest still hides archaeological sites that were thriving cities just 500 years ago. Satellite imagery only recently revealed their traces. If dense jungle can erase evidence of a civilization in centuries, what can millions of years do? Even in deserts, where preservation seems easier, time is merciless. Wind scours stone, sand buries, and then reveals, only to bury again. Without active maintenance, even the pyramids of Giza will one day erode into indistinct mounds of rubble, and they are among the most durable human structures ever built. Now push your imagination further. Think of a technological species that never built in stone at all, one that lived in floating structures, or in the oceans, or underground, or using bioengineered materials designed to decay. Such a civilization could transform the planet without leaving a single recognizable artifact. Its only legacy might be a subtle chemical shift, one that we'd dismiss as natural. There's a lesson here about our own future, too. We assume our legacy will be obvious: satellites, skyscrapers, data centers. But the half-life of memory is short. Satellites will tumble and burn. Data centers will corrode. Languages will mutate. Digital archives will vanish. Our civilization's most enduring message may be the layer of altered sediment and climate signals we're making right now. And yet there's also resilience. Some things can last astonishingly long. Ceramic and glass can survive for millions of years under the right conditions. Certain synthetic molecules may remain stable indefinitely in cold, dark sediments. Buried archives in geologically stable regions could persist far longer than surface cities. But even then, discovery depends on chance. A future geologist drilling in just the right spot. All of this reveals a paradox. To leave a mark that survives deep time, you must act on a planetary scale. But the more powerful your planetary influence, the more likely it is to destabilize the environment that supports you. Industrial activity changes climate, chemistry, and ecosystems. A technological species powerful enough to alter the Earth forever might also be powerful enough to trigger its own collapse. And after collapse, only traces remain. This paradox makes the search poignant. We're looking for echoes of a civilization that, if it existed, may have been very much like us. Brilliant, ambitious, vulnerable. We're also glimpsing our own possible future, a world where our monuments are gone, our myths are forgotten, and our only fingerprint is a thin chemical layer in stone. If nothing else, the Silurian Hypothesis encourages humility. It's a thought experiment that forces us to see Earth not as our stage, but as a long-running story, with chapters written and erased before we arrived. It shows that permanent is an illusion, and that even intelligence and industry don't guarantee remembrance. So as you hear these words, picture the layers under your feet. Picture the invisible signatures in ice cores, sediments, and minerals. Somewhere in those layers, there might be a clue we've missed. Not a buried city, but a buried signal. A message not in letters, but in chemistry, waiting for someone to decode it. Let's take a moment and imagine how a future scientist might work. Millions of years from now, tectonic plates have drifted. Mountain ranges we know have eroded to low hills. Seas have opened and closed. The continents themselves have shifted like slow dancers. In a quiet lab, a future geologist studies a core sample drilled from deep rock. They see an unusual layer, a sharp spike of carbon, odd isotopes, microparticles of strange polymers. They know it means something, but what? Without artifacts, context is everything. A chemical signature can hint at disaster, at life, at technology. But the same signature could come from volcanoes, asteroid impacts, or runaway climate events. The scientist tries to model the possibilities. The data doesn't speak in human terms. It only says, something changed here, fast and hard. Now step back and realize, we are living inside the signal we're creating. Every barrel of oil burned, every reactor run, every factory built, all of it is a line written into Earth's deep archive. We don't know how long it will last, but we do know it's happening now. We are the experiment whose outcome we're trying to guess. This is why thinking about lost civilizations isn't just a curiosity, it's a mirror. By asking, what if someone came before us? We're also asking, what will we look like to someone after us? The question becomes a bridge across time, connecting us to possible pasts and inevitable futures. It also changes how we read myths. Flood stories, golden ages, cosmic punishments. They become not just moral tales, but potential records of environmental upheavals. They show how humans compress catastrophe into narrative, how we remember disaster as story. If an ancient technological species experienced a collapse, what would remain? Probably not their machines, but perhaps their descendants' myths, retold, distorted, merged with cosmology, might echo faintly even now. Modern science is starting to integrate these ideas. Archaeologists use satellite data, ground-penetrating radar, chemical tracers. Geologists look for technofossils, objects or substances that can't be produced naturally. Climatologists model long-term feedback loops that might persist for eons. All these tools come together in the search for signals in deep time. There's even a cosmic angle. Astronomers look for technosignatures, evidence of advanced civilizations on other planets, waste heat, atmospheric anomalies, megastructures blocking starlight. But the same logic applies here on Earth. We're searching for technosignatures in our own past, buried not in the sky, but in the crust beneath our feet. If we do find something, it will probably be subtle. A pattern in isotopes across multiple continents, an anomaly in ocean sediments consistent with synthetic compounds, a sudden global shift in ratios of rare elements. No monuments, no inscriptions, no clear artifacts, just a statistical fingerprint, like a ghost in the data. That means the biggest obstacle may not be the absence of evidence, but our own imagination. We have to learn how to see what we're not expecting. We have to be willing to ask questions that sound absurd, to test hypotheses that don't fit our current models. Otherwise, we risk overlooking the extraordinary hidden inside the ordinary. And there's a poetic side to all this. Thinking about deep time and lost civilizations pulls us out of the everyday. It reminds us that we're temporary, fragile, and part of a much larger story. It turns our gaze from our own monuments to the processes that made and will unmake them. It shows that knowledge isn't just about answers. It's about the courage to ask questions, whose answers may never come. In the end, the search for lost civilizations isn't about proving a specific theory. It's about expanding the map of the possible. It's about training our eyes to see faint patterns, training our minds to imagine scales of time beyond our instinct. It's about humility and wonder. So where does this leave us? We've journeyed from the molten heart of geology to the fragile strands of myth. We've watched cities dissolve, oceans rise and fall, and entire worlds slip beneath sediment and time. And through it all, one idea stands. Permanence is an illusion. Everything we build, everything we know, is part of a vast and patient cycle. If another civilization existed millions of years ago, its monuments would be gone. Its stories would be myths. Its fingerprints would be scattered molecules in stone. And yet, that doesn't make the idea pointless. It makes it profound. Because by imagining their erasure, we understand our own. Think of our satellites orbiting now, glittering like a necklace of light. In a few centuries, they'll be debris. In a few millennia, dust. Our cities, our art, our data, all fading. But in the rocks, perhaps, a thin layer of altered chemistry will persist. A quiet record that we were here. A record no one may ever read. And maybe that's enough. Maybe the point of life isn't to be remembered forever, but to add your verse to the larger story, knowing that story is written and rewritten across ages. We are temporary, but we are part of something vast. This perspective changes how we see Earth, not as a stage built for us, but as an ancient world with its own rhythms, its own experiments, its own memory. It invites humility. It invites curiosity. It invites us to look at our footprint, not just as a cost, but as a message, not to future humans, but to whoever or whatever comes after. Imagine, millions of years from now, a new species stands where you are now. They know nothing of you. They've never heard of our languages, our wars, our art. But deep under their feet, they find a strange layer. Altered carbon, rare isotopes, fragments of polymer. A puzzle. They may never know our names, but they'll know something happened. Something powerful enough to bend the planet itself. That's the legacy we're leaving. Not marble statues, but planetary chemistry. Not epics, but isotopes. Not permanence, but change. And in this realization, there's a strange kind of freedom. We don't control the future. We don't control memory. But we do control our choices now. We can decide whether our fingerprint is one of collapse or of stewardship. We can choose to leave behind chaos or balance. The Silurian Hypothesis started as a playful thought experiment. It has become a mirror. It shows us how small we are in deep time and how extraordinary. We are one of the few species on Earth to even think about deep time, to imagine predecessors and successors, to question our place in the planet's story. As you finish this journey, look at your hands, at the ground beneath your feet, at the sky overhead. All of it has been here for billions of years. All of it will be here long after we're gone. transformed, but still part of the whole. Somewhere, deep below, the stone is writing its slow, patient record, and maybe, just maybe, someone far in the future will pause, drill, and wonder about us, the same way we wonder about them. That possibility, that unbroken thread of curiosity across unimaginable time, may be the truest monument any civilization can hope for. We've been looking backward, but what if we look sideways, at other planets? Mars once had rivers, lakes, maybe even oceans. Venus may have been temperate before its runaway greenhouse effect. Both worlds could have hosted life, maybe even complex ecosystems. If intelligence arose there, it would be gone now, leaving only ambiguous traces. We'd be trying to read them from orbit, just as we try to read Earth's deep past from a handful of cores and rocks. This planetary perspective helps us see our own world more clearly. Earth is not unique in its ability to erase. Every active planet is a recycling machine. Lava plains cover craters, winds scour cliffs, dust storms bury evidence. Even on the moon, without air or water, meteors pummel the surface, grinding it slowly into powder. Deep time is universal. Now imagine a truly alien civilization, not human-shaped, not bound to stone or steel. Maybe it grows cities like coral reefs, living architecture that dissolves when abandoned. Maybe it encodes memory in genetic patterns rather than writing. Maybe it disperses into spores or seeds, leaving no industrial ruins at all. If such a civilization rose on Earth long before us, would we recognize it as civilization, or would we dismiss it as a natural phenomenon? This thought stretches our definitions. We equate technology with metals, wires, engines. But intelligence might manifest as ecological engineering, genetic manipulation, or purely digital systems stored in biomatter. All of these could leave different kinds of signatures, or none that we'd recognize. We could be surrounded by subtle evidence and not even know how to look for it. Some researchers have proposed technofossils, enduring materials or configurations that can't arise naturally. Examples could include high-purity metals, complex alloys, or isotopic ratios impossible in nature. But even these may degrade, dissolve, or be remelted by tectonics. The deeper you go in time, the thinner your net becomes. Yet it's not hopeless. We're developing new tools: mass spectrometry, deep drilling programs, seafloor mapping, isotope analysis at unprecedented precision. Machine learning can scan vast data sets for anomalies we'd miss. Every decade, our ability to see faint signals improves. What looks invisible today could become obvious tomorrow. And there's another path. Not just physical traces, but indirect evidence. If an ancient civilization triggered a mass extinction, altered atmospheric composition, or changed the distribution of minerals, we might infer its existence without ever finding its artifacts. We might reconstruct its story the way we reconstruct ancient climates, from proxies, not direct observation. This kind of inference is already familiar in astronomy. We can't see exoplanets directly, but we infer them from wobbles in starlight. We can't see dark matter, but we infer it from gravitational effects. In the same way, we might never find an ancient machine, but still deduce that something once acted in a coordinated, technological way on Earth. And what if we never find anything? That too is a result. It would tell us something profound about the rarity or fragility of technological intelligence. It would show that even on a planet as rich and diverse as Earth, intelligence arose only once in billions of years, or that it arose before and inevitably self-erased. Either way, it reframes our story from "we are unique" to "we are part of a cosmic experiment." Thinking in these terms also helps us prepare for the future. It forces us to ask, what is truly durable? What could survive as a beacon, a marker, a self-explaining artifact across millions of years? How would you design a message for an audience who may not even be human, who may not share our senses or symbols, who may live on a shifting, erasing planet? Some scientists have even proposed building stratigraphic beacons, patterns in rock layers designed to persist and be recognizable as artificial. Others imagine leaving massive structures on the moon or in stable orbits beyond tectonic and erosional processes. Yet even those could be sandblasted by micrometeoroids over geological time. Immortality in matter may be impossible, but the act of thinking about it changes us. It pushes our imagination, our engineering, and our sense of responsibility. It turns deep time from an abstraction into a stage where we can glimpse ourselves, not as permanent rulers, but as temporary actors. If you wanted to design a message for deep time, how would you do it? You couldn't rely on language. Words drift, alphabets mutate, meanings fade. You couldn't rely on paper or digital media. They crumble, they rot, they become unreadable in centuries. Even stone carvings erode. So you'd need to think like a geologist, not like a writer. Some thinkers propose encoding messages in stable isotopes or layered patterns of minerals. Others imagine carving symbols on an enormous scale, kilometer-long trenches or raised ridges visible from orbit. Still others suggest altering DNA of hardy organisms to carry a code, letting evolution replicate it for millions of generations. Each approach has trade-offs, but all share one theme: durability through integration with natural processes, not defiance of them. We can see hints of this thinking in projects like the Long Now Foundation, which builds mechanical clocks designed to run for 10,000 years, or in the Voyager spacecraft's golden records, launched beyond the solar system to outlast Earth itself. These are baby steps toward deep-time communication. But even they may not survive forever. Radiation, collisions, cosmic dust, nothing is immune. Imagine, then, that an ancient civilization tried something similar. Maybe they seeded minerals with rare isotopes, sculpted global patterns, or modified the genomes of long-lived species to carry a signal. We might be walking through their message right now without recognizing it. Our assumptions about what counts as artificial limit our ability to see. This is why interdisciplinarity matters. Geologists, chemists, archaeologists, astronomers, linguists all have pieces of the puzzle. By combining methods, we may detect patterns invisible to a single field. A sudden spike of a rare compound in marine sediments might seem meaningless until matched with a myth about a sky fire or a geological anomaly thousands of kilometers away. It also changes how we see our own legacy. If we care about being remembered, we have to think on scales we're not used to. What kind of artifact could carry not just proof we existed, but also a hint of who we were? Could we leave a self-explaining Rosetta Stone for beings who know nothing about us? Could we encode our story in a form so simple and universal that it crosses species and epochs? Some argue we should abandon the quest for permanence. Instead of trying to leave a monument, we should focus on living sustainably now, knowing we're temporary. Others argue for both. Live sustainably, but also plant markers, like cosmic seeds, carrying our story into the future. And there's the psychological angle. Contemplating deep time shifts our sense of self. Daily worries shrink. Achievements feel both smaller and grander. We're humbled by our brevity, but also awed by our ability to imagine beyond it. This double vision, being tiny and vast at once, is uniquely human. It also brings a kind of peace. If civilizations can rise and fall without a trace, then our failures aren't the end of the world. But it also brings a warning. If civilizations can vanish so completely, then survival is not guaranteed. We are fragile, our environment is fragile, and time is relentless. So as you watch this video, think of yourself as part of a chain. Before you, perhaps others wondered the same things. After you, others will too. Curiosity is the real constant. It's the only signal that might survive everything else, not as a fossil, but as a tendency, a drive written into any intelligent mind. Maybe that's the ultimate techno-signature, the question itself. The impulse to look back and forward, to imagine the unseen, to connect across time. If intelligence arises elsewhere in the cosmos, it might not build cities or satellites, but it will wonder. And in wondering, it will leave its mark, if only in the questions it asks of the universe. Let's push our imagination even further. Suppose a future archaeologist from another world lands on Earth long after we're gone. They're not human. Their senses differ from ours. Maybe they see in ultraviolet or detect magnetic fields as clearly as we see color. They wander across a landscape that to us would seem familiar, but to them is alien. What would they find? They might stand on what used to be a continent, now fused with another, mountains risen from old seabeds. They might sample a cliff and find a faint layer of altered chemistry, a sudden spike of synthetic compounds. They might notice subtle patterns in mineral grains, alignments left by ancient construction or mining. But without context, it's just data. Would they recognize it as evidence of civilization or assume it was some natural oddity? This thought experiment reveals a blind spot. We tend to assume intelligence looks like us, builds like us, leaves ruins like ours. But if intelligence has arisen before, on Earth or elsewhere, it could be radically different. We might be missing signals because they're not shaped the way we expect. We might be mistaking design for geology, art for biology, technology for weather. It's like walking through a forest and not recognizing a hidden animal because it's camouflaged. Only when it moves do you see the pattern. Deep time is the ultimate camouflage. Everything moves so slowly that patterns blend into the background. We already have examples of misinterpretation. For decades, scientists thought certain fossils were just odd rocks, until someone looked closer and saw the outline of an ancient creature. Entire categories of evidence shift meaning as our theories change. What we call natural today could be reclassified tomorrow. This is why continued curiosity is essential. The more we know about Earth's natural processes, the better we can spot anomalies. The more we understand about self-organizing systems, the better we can recognize when something breaks the pattern. And the more we cross disciplines, the more likely we are to catch faint signals hiding in plain sight. Think about the first people to realize that the continents drift. For centuries, the idea was ridiculed. Today, it's accepted as obvious. The same could happen with the idea of ancient civilizations. Right now, it's speculative. In the future, it could become a mainstream field of study with robust methods. Or think of the first discovery of deep time itself. Early geologists thought the Earth was only a few thousand years old. Now we talk comfortably about billions. Our sense of scale keeps expanding. Maybe our sense of civilization will too. There's also a hopeful message hidden here. If civilizations can rise and fall without a trace, then intelligence might be more common than we think, not less. We may not be alone in the cosmos. We may not even be alone in Earth's history. The universe could be teeming with minds, each leaving subtle fingerprints, each flickering across eons. But it's also sobering. If intelligence tends to self-erase, then longevity is rare. The window of visible activity may be brief. That means our own choices matter enormously. We stand at a hinge point between obscurity and legacy, between being a transient signal or a lasting influence. This duality, hope and warning, gives the Silurian hypothesis its power. It's not a claim, it's an invitation to think bigger, to look deeper, to plan further. It says, imagine the impossible, then test for it. Even if you find nothing, you'll have learned more about your world and your place in it. And maybe that's the real goal. Not to prove an ancient civilization existed, but to sharpen our perception, to refine our science, to cultivate humility and awe. These are qualities every civilization needs if it hopes to last. Think of the planet as a giant memory crystal. Every river, every eruption, every storm etches a mark. But unlike our digital drives, this crystal rewrites itself, melting old memories into new ones. Reading it is an art and a gamble. We find fragments, hints, ghosts of processes long gone. But sometimes, if we're lucky, we catch a glimpse of something unexpected. Imagine drilling deep beneath the Antarctic ice and finding a layer rich in strange molecules no microbe can make. Imagine pulling up a core from the Pacific floor and discovering a band of minerals with properties unknown in any natural deposit. Imagine scanning ancient rocks with ultra-precise instruments and finding nanostructures, microscopic but unmistakably engineered. How would we react? Would we even recognize them? Science thrives on such what-ifs. It doesn't need certainty to begin the search. It needs only curiosity and rigor. Each anomaly becomes a question mark. Each question mark pushes technology forward. The search for ancient civilizations on Earth may never yield a definitive yes. But along the way, it will give us sharper tools for understanding our planet, our climate, and our future. It also reminds us of scale. Our personal lifetimes are tiny. Our recorded history is short. Yet even in that short time, we've reshaped the biosphere. If a future species studies our layer, they'll see extinction pulses, carbon spikes, sudden shifts in nitrogen cycles, traces of synthetic chemicals. They'll see our industrial heartbeat frozen in stone. But maybe the most enduring legacy isn't physical at all. It's the mindset, the willingness to ask questions across unimaginable time. To be a species that not only builds, but also wonders, not only consumes, but also reflects. In a sense, every question about ancient civilizations is also a promise to future ones. We are thinking of you, even if we'll never meet. This perspective can influence our choices. If we know our legacy will be thin and chemical, maybe we'll act with more care. If we know myths can outlast monuments, maybe we'll tell better stories. If we know future beings may find only fragments, maybe we'll plant clues that help them understand. There's also an emotional dimension. Contemplating deep time can be both terrifying and comforting. Terrifying because it shows how little we matter in cosmic scales. Comforting because it shows that everything passes. Pain, conflict, even species. And inspiring because it shows that curiosity itself is timeless. It may arise wherever intelligence arises, like a flame that lights itself again and again across the universe. We stand at a threshold. We can continue as we are, leaving a confused signal of excess and collapse. Or we can deliberately craft our layer, choose what traces to leave, and perhaps in doing so, extend our presence far beyond our physical survival. This isn't about immortality, but about stewardship, of knowledge, of planet, of possibility. In the end, the question, were we first, becomes a question, will we last? We cannot control how we'll be remembered, but we can control how we live now. And maybe that's the truest lesson of the Silurian hypothesis. To live as if someone, someday, will read our signature and try to understand. And if no one ever does, that's all right too. The act of wondering connects us to all who've wondered before and all who will wonder after. It's our link across time, our invisible monument, our fingerprint in the flow of deep history. Close your eyes for a moment and imagine the entire timeline of Earth compressed into a single day. Midnight marks its birth. At 4 a.m., the first oceans appear. By 1 p.m., bacteria thrive. By 9 p.m., multicellular life blooms. Dinosaurs show up around 10:30 p.m. Humans, we appear a few seconds before midnight. Everything we call history is a fraction of a blink in that cosmic day. Now ask yourself, if another civilization arose at, say, 7 p.m. on that same day, how likely is it that we'd find its traces now? Mountains formed and eroded. Oceans opened and closed. Ice sheets advanced and retreated. Whole continents shifted. It's no wonder the past seems empty. Deep time is a relentless editor. This compressed perspective drives home how audacious our search really is. We're not just looking for needles in haystacks. We're looking for faded shadows of needles in haystacks that have blown away. Yet still, we look. Because the search itself changes us. It teaches patience, scale, and wonder. It also invites us to see our present differently. The highways, skyscrapers, and satellites that feel permanent are just momentary arrangements of matter. The real continuity lies in cycles of carbon, nitrogen, water, and curiosity. We are temporary patterns in a larger flow, and our mark on Earth will be a thin band in stone, not a monument visible from space. But within that thin band, we have power. We can choose what kind of signal we leave. Will it be a scar of destruction or a testament of care? Will it show collapse or stewardship? Even small shifts now, in energy, in culture, in narrative, can echo into the deep future. We may not control time, but we control our contribution. Imagine far ahead, a being who drills into the rock and reads our layer. They see our industrial pulse, our sudden impact, our brief blaze of activity. Maybe they wonder about us as we wonder about them. In that moment, across millions of years, two minds connect, not directly, but through a shared curiosity. That's the quiet magic of thinking in deep time. And there's a final paradox. The more we accept our impermanence, the more meaningful our actions become. Knowing we're temporary pushes us to act with intention, to savor the present, to create beauty and knowledge without clinging to permanence. If our only guaranteed legacy is a chemical trace, then let it be a trace worth leaving. So, were we first? We don't know. Will we last? We don't know. But we do know this. We're here now, thinking these thoughts, asking these questions, connecting across time. That alone is extraordinary. In a universe where most matter drifts silently, we're a brief moment of self-awareness, of reflection, of story. As this journey ends, remember, deep time is not empty. It's full of possibilities, full of stories unwritten and erased. Maybe ours will be one of them. Or maybe, by understanding the fragility of memory and the power of our choices, we'll find ways to endure. Not forever, but long enough to leave a signal that whispers across the ages. We were here, we wondered, and we cared. Let's build a picture together. Imagine a civilization so old that dinosaurs were still roaming under its skies. It does not look like us. It does not think like us. But it is intelligent, deeply, powerfully intelligent. It emerged not in a desert or on a savanna, but in the warm, shallow seas of a vanished continent. Its cities are not towers of stone, but living reefs of engineered coral, humming with bioelectric signals and patterned growth. This species never invented fire in our sense. It harnessed chemistry, not combustion. It learned to program organisms rather than forge metal. Its ships were vast floating gardens, weaving nutrients into a lattice of memory. Information stored in shells, in pigments, in vibrations across networks of symbiotic creatures. Buildings that photosynthesized by day and glowed by night. Infrastructure grown like orchards, trimmed and harvested, then regrown again. From our perspective, nothing it made would survive. No steel, no concrete, no plastics as we know them. Instead, there were flexible composites, self-healing biofilms, soft robotics. When abandoned, they would revert to natural states, dissolve into ocean currents, or be eaten by descendants of their own designs. Within centuries of collapse, only traces of altered sediment and strange isotopic footprints would remain. Its energy was drawn from gradients, thermal vents, tidal forces, bioengineered photosynthesis. It had no need for fossil fuels, so it left no soot layers or sudden carbon spikes like ours. It transformed ecosystems subtly, moving species across oceans, sculpting coastlines, planting entire kelp forests to stabilize currents. In time, it spread across the seas, a network of glowing, singing, growing machines. Then came a catastrophe, maybe a supervolcano, maybe a massive asteroid, maybe a runaway experiment. Its living cities died. Its engineered organisms became food for wild ones. Its networks flickered out. Within centuries, the ocean reclaimed everything. Within millions of years, tectonics buried the coastlines. Its memory dissolved like salt. Now picture us, tens of millions of years later, drilling a core from a long subducted shelf. We find a thin band of weird isotopes, a spike in rare minerals, traces of proteins we can't identify. We argue. Some say natural anomaly. Some say ancient life. A few whisper technology. But without context, without a Rosetta Stone, it's just a puzzle. This thought experiment isn't fantasy for its own sake. It shows how differently intelligence could develop and how easily it could vanish without leaving the kinds of ruins we expect. It also flips our assumptions about what advanced means. Maybe the most advanced civilization isn't the one with the biggest skyscrapers, but the one whose infrastructure merges so seamlessly with nature that it leaves almost nothing behind. And maybe, if we learn from this vision, we can also see our own path differently. We too could choose to build in ways that dissolve gracefully rather than scar permanently. We could design our legacy to be gentle, to fade into Earth's cycles rather than defy them. If we did, a future scientist might still find our fingerprint, but it would be a soft one, an echo rather than a wound. This is the power of imagining ancient civilizations. It's not about believing in lost continents. It's about expanding our concept of possibility. It frees us from thinking technology must be noisy, metallic, and obvious. It invites us to search for signals in the subtle, the biological, the integrated, to see the ocean as a library, not just an eraser. Let's push our speculative vision one step deeper. If an ancient civilization arose millions of years ago, how might its intelligence have expressed itself? We tend to imagine AI as silicon chips and data centers, but an earlier civilization could have taken a completely different path. Picture an intelligence that never separated machine from organism. Its AI is a network of living cells, tuned to compute, to store, to model. Memory as protein folding, decision-making as biochemical cascades, creativity as emergent behavior from thousands of symbiotic creatures acting as one. Instead of building external computers, they sculpted internal ecosystems. Their thinking was distributed, like coral reefs or fungal networks, spanning oceans in living webs. Such a civilization would produce art and culture unlike anything we know. Not paintings or books, but patterns in reefs, melodies in currents, colors in migrating schools of engineered fish, festivals of synchronized bioluminescence sweeping across hundreds of kilometers of water, architecture as seasonal blooms, storytelling through gene expression and timed displays, culture that lives and dies with the tide. From our vantage, nothing of this would look like technology. We'd see only reefs, shells, or sediments. Their most enduring artifacts might be new species, altered ecosystems, or persistent genetic codes woven into long-lived organisms. But to them, these were libraries, theaters, and networks. Think about how differently time would feel in such a society. Where we build and demolish, they would grow and harvest. Where we store data in fragile chips, they would encode it in lineages, letting it flow across generations like a living river. Collapse might not be a sudden event, but a slow unraveling, a drift back to wildness. And when it ended, nothing artificial would remain except subtle signatures in biodiversity and sediment. This perspective reframes our own definitions. We equate progress with hard infrastructure, but progress could also mean deep integration, invisibility, resilience. The most advanced civilizations might be the ones whose presence you barely notice, because they've learned to merge with their planet rather than dominate it. It also gives us a new way to look at Earth today. Are there anomalies in genetics, in ecosystem patterns, in mineral distributions that hint at past intervention? Could we be living among the descendants of someone else's designs? We don't know. But this line of thinking opens entirely new fields of inquiry. And perhaps most importantly, it shows us another path for ourselves. We could design technology to be biodegradable, networks to be symbiotic, culture to be regenerative. We could choose an evolution toward invisibility rather than monumentality. If we did, our legacy might be less obvious, but more harmonious. A fingerprint of stewardship rather than disruption. The point of imagining isn't to claim, it's to expand our searchlight. It's to remind us that intelligence and civilization are not bound to one template. They can arise in many forms, leave many kinds of traces, and vanish in many ways. By broadening our sense of the possible, we sharpen our eyes to the improbable. And somewhere in that improbability, maybe, a faint signal waits. A pattern in genomes, a chemical echo in stone, a whisper across deep time saying, "You're not alone." Now let's step inside their minds. Imagine an ancient civilization whose philosophy is built not on permanence, but on flow. Where we carve in stone, they compose in currents. Where we print books, they weave stories into migrating schools of bioengineered creatures, each carrying a fragment of memory. Their libraries are alive, moving across oceans, singing their contents at dawn and dusk. Their art is not a static object, but a living performance. Bioluminescent spirals blooming in coral networks, genetic tapestries shifting color with the tides, soundscapes resonating through miles of engineered kelp forests. Culture is not archived. It's experienced, renewed, passed through living channels like a pulse. Their spiritual life reflects deep time. They do not see themselves as separate from their planet, but as one of its passing currents. Time is not linear, but tidal. They don't write history, but cycles. Collapse is not tragedy, but transformation, an ebbing before a new flow. In this worldview, leaving no permanent trace is not failure, but fulfillment. To merge back into the ocean is the highest art. To us, this would seem invisible. Without stone inscriptions, without metallic debris, without monuments, we'd never know their thoughts. Yet in their own frame, their legacy is everywhere. In the genes of species they shaped, in the currents they stabilized, in the chemical gradients they tended. They might even have looked at the stars. Not with telescopes of glass and steel, but with sensors woven into plankton swarms, turning the ocean into a giant eye. They might have mapped cosmic radiation with bioluminescent markers, used the rhythms of planets to time their migrations, tuned their culture to cosmic cycles. They could have known the heavens as intimately as we know our screens, but in a language of tides and orbits. And perhaps they, too, wondered about predecessors. Perhaps they found odd signals in ancient sediments, built myths about beings before them, speculated about their own deep past. Curiosity may be the one universal constant of intelligence, arising whenever minds arise, reaching backward and forward across the abyss of time. This is where our stories overlap. We, too, are trying to read a record that was never written for us. We're trying to sense patterns older than our species, to map a tapestry of causes and consequences across billions of years. And in doing so, we're practicing a kind of communion, not with aliens or ancestors, but with the planet itself. Thinking about such a civilization shifts our self-image. We're not a lonely pinnacle, but one experiment among many. We're not permanent, but neither are we trivial. We're a flash of awareness in Earth's long dreaming, a temporary configuration of matter that wonders about itself. And as you imagine their cities dissolving, their memories drifting back into salt water, realize that this too can be beautiful. Impermanence isn't just loss, it's also participation. It's being part of something larger than any one species, larger even than life. In that sense, whether or not they ever existed, they already teach us. They show us an alternative model of civilization, one that's soft, integrated, regenerative, and humble. And perhaps in considering them, we might choose to become more like that ourselves. Push the vision one step further. Suppose that ancient civilization, after mastering its oceans and its planet, looked upward and outward. It began to expand beyond Earth, but in ways very different from our rockets and satellites. No metal starships streaking through the sky, no dramatic launches. Instead, it sent spores of technology, seeds of intelligence, drifting on solar winds, embedding themselves in asteroids and comets. A slow, patient expansion. Perhaps it engineered organisms to survive in vacuum, turning small icy bodies into living laboratories. Perhaps it built reef-like colonies on near-Earth objects, subtle structures that looked like minerals, but pulsed with bioelectric signals. Over millions of years, these living machines could have migrated through the solar system, feeding on sunlight, cosmic dust, or magnetic fields. If such a civilization existed, our telescopes today might not even notice its traces. We'd dismiss them as ordinary asteroids or comets. Their probes wouldn't shine like metal, but glow faintly in spectra we rarely check. Their archives might be encoded in complex ice crystal patterns, not in binary code. Their messages might be biochemical symphonies triggered by starlight. This also reframes how we think about technosignatures. We're searching for Dyson spheres, radio signals, industrial pollutants. But an ancient biotechnological civilization could leave signatures more like lichen on rocks or microbe mats on ice. Subtle, distributed, hidden in plain sight. We could be looking at it and not know. Even their departure from Earth could leave only a chemical echo. Perhaps they mined certain minerals extensively, altering isotope ratios in a way we can't yet measure. Perhaps they seeded life forms whose descendants still swim in our oceans, carrying fragments of their design. Or perhaps they deliberately erased themselves, choosing to blend back into the biosphere rather than linger as ruins. Thinking about their cosmic phase also throws light on our own trajectory. We imagine a future of colonies on Mars, outposts on moons, starships to distant systems. But deep time suggests another possibility, spreading slowly, invisibly, embedding ourselves in biology rather than metal, leaving signatures in genetics rather than radio waves. We could become a cosmic reef rather than a galactic empire. And maybe, in some far future, another intelligence will find a subtle anomaly in an asteroid belt or a genetic code and wonder if someone came before. Curiosity will ignite again. The thread will continue. This cosmic perspective gives our story a new scale. We're not just inheriting a planet. We're participating in a continuum of minds that may extend beyond planets. Whether we're the first or the thousandth doesn't matter as much as whether we continue the chain of curiosity and care. So, as you listen to these words, picture not just Earth's deep past, but the solar system's deep future. Imagine traces drifting in the dark, seeds, spores, coated ice, a silent chorus of ancient ambitions. Perhaps some of them are already out there, orbiting quietly, waiting to be recognized. And perhaps, just as we now stand on the edge of imagining them, someone, somewhere, is imagining us. Every story needs an ending, even one told across millions of years. If our hypothetical ancient civilization reached the stars or seeded the solar system, something must have brought that chapter to a close. Perhaps it was a slow decline, not a cataclysm. Resources spread thin, curiosity dimmed, generations turned inward, or perhaps a sudden catastrophe, a gamma-ray burst, a rogue asteroid, a biological runaway. In deep time, endings are inevitable. But endings don't always mean failure. They can also mean transformation. A civilization can dissolve, not because it collapsed, but because it transcended, merged with its planet's biosphere, converted its consciousness into distributed forms, or simply chose to fade. Its energy and information might still flow in ways we cannot perceive, woven into the planet like hidden threads. This thought should be both sobering and inspiring. Sobering because it shows that even mastery of a planet or a solar system doesn't guarantee permanence. Inspiring because it shows there are many paths beyond the narrow one we know. We're not doomed to follow the same arc. We can choose differently. It also reframes our concept of success. We often equate success with survival, expansion, accumulation. But perhaps success in deep time is measured by integration, balance, and the ability to pass gracefully into the next cycle without leaving scars. Perhaps the greatest legacy is not to dominate, but to harmonize. For us, standing at the edge of the Anthropocene, this is a powerful lesson. We can keep chasing monumentality, or we can begin thinking like caretakers of a living archive, crafting a layer in Earth's memory that tells a story of awareness and restraint. We can choose to leave a signature of renewal rather than extraction. And even if we fail, there's still meaning. The act of wondering connects us to all minds before and after. In a universe where most matter drifts silently, we're a brief moment of self-awareness. Whether we last or not, the fact that we ask these questions is extraordinary. Picture a future being holding a sample of rock containing our time. They don't know our names or our languages, but they see the layer. They see the sudden change. They feel the echo of a story. In that moment, across millions of years, we're connected. Our curiosity reaches them. Their curiosity reaches us. This invisible handshake across time may be the most enduring monument any civilization can create. And here's the final paradox. By accepting impermanence, we free ourselves to act with intention. Knowing our monuments will fade pushes us to focus on what matters: compassion, creativity, curiosity. These qualities may not leave fossils, but they leave ripples, influencing generations in ways we can't predict. So as this extended journey draws to a close, remember, deep time is not a void, but a tapestry. We are a thread woven briefly through it, bright and fragile. Maybe we're the first, maybe we're not. Maybe someone will read our layer, maybe not. But in wondering, we become part of something vast, a continuum of minds stretching backward and forward beyond the reach of memory. And perhaps that, more than any monument or machine, is what endures. And now, as our journey through deep time ends, take one last look at the ground beneath your feet. Inside those silent layers lie the echoes of oceans, forests, storms, and perhaps long-forgotten dreams. We may never know if someone came before us, but by daring to imagine it, we step outside our own brief moment and touch eternity. In the end, that's the real treasure of this search. Not monuments of stone, not answers carved in certainty, but the widening of our perspective. The ability to see ourselves as part of a story, larger than any one species, larger even than life itself. So when you walk outside tonight and feel the wind on your skin, remember, you are a flicker of awareness in Earth's ancient memory, adding your own verse to an endless poem. Whether or not anyone reads it millions of years from now, it exists now, vivid, fragile, and extraordinary. And maybe, just maybe, far in the future, another mind will pause over a fragment of stone, a trace of chemistry, a whisper in the data, and feel a spark of recognition. In that instant, across unfathomable time, two stories meet, ours and theirs, a silent handshake across the ages. That is our legacy, that is our gift, and that is enough. Thanks for traveling with Journey Through Time. Until next time.